Distance between the file tip and the radiographic root apex is taken into account. So what is the first step? We take a pre-op radiograph of the tooth. We take a pre-op between the file tip and the radiographic root apex. We take the preoperative radiograph, and on this preoperative radiograph we measure tooth length. Suppose this is preoperative radiograph of a particular tooth into which we are planning to do root canal. This is how the tooth appears on the radiograph, suppose. Okay. So from this coronal reference point to the root apex, we would measure the tooth length completely. Complete length of the tooth is measured on the preoperative radiograph. And this length, just to give an example, is suppose 21 millimeters. Okay. Means the length from the coronal reference point to the terminus of the root radiographic apex is 21 millimeters, suppose. Then we would subtract 1 millimeter safety factor, and it would give you tentative working length is 21 minus 1, that is 20 millimeter. Isn't it simple? Because our purpose is that the root canal procedures should terminate at the apical termination 1 millimeter short from that. Isn't it, at the apical constriction? So we consider 1 millimeter as the safety factor. From the total length of the tooth, we would subtract 1 millimeter and we would get TWL, that is tentative working length. Now, second step, what we would do, we would take an endodontic file. Okay. And set the stopper at tentative working length, that is 20 millimeter. We all know there is a stopper on the files. We would set the stopper at 20 millimeters and insert it into the prepared access cavity, and then take second radiograph. We take radiograph with file inside the tooth. We take radiograph with file inside the tooth. And how much is the length that we have inserted inside the tooth? At the tentative working length, which is 1 millimeter short of the total length of the tooth measured on the preoperative radiograph. Okay. And simply, after taking the radiograph, in the fourth position, we have to measure distance between what two things we would measure the distance between the file tip on the X-ray and root tip or the root end on the X-ray. Okay. Previously, I've told you these are the two measurements that we have to keep in mind, the file tip and the root tip. Suppose in this radiograph that you have taken after inserting the file to the tentative working length, you get something like this on the radiograph. The tip of the file is bang at the root tip. Then what would be your final working length? Final working length would be tentative working length minus 1 millimeter, because always remember 1 millimeter is the safety factor in the guidance used in Ingalls method. The tip of the file should be 1 millimeter short of the radiographic apex of the tooth. In our scenario, at the tentative working length, the file was apposed or exactly at the root tip, so the final working length would be tentative working length minus 1 millimeter. If I talk about second scenario, suppose you have taken a radiograph with the file inserted, okay, and you get a situation like this. The file is inserted at the tentative working length and the distance between tip of the file and the root apex is 1 millimeter. Then what would be your final working length? It would be equal to tentative working length, that is 20 millimeter in our case. Suppose you get a scenario like this, that this is the root tip, but the file tip when inserted at the tentative working length is 1 millimeter beyond the apex. Then what would be final working length? We have to keep the tip of the file 1 millimeter short of the root apex. So final working length would be tentative working length minus 2 millimeters, isn't it? 1 millimeter for this and 1 millimeter the safety factor. That is 21 minus 2, that is 19 millimeters. So this is how we assess the Ingalls method to determine the working length in a radiographic manner. What you have to remember, the distance between tip of the file and the radiographic apex should be 1 millimeter. And if it is so, it would be a final working length. I have given you 3 examples of clinical situations. The clinical situations and the dimensions may vary. Accordingly, you have to adjust and make the distance between the file tip and the root tip to be 1 millimeter. This is the Ingalls method of working length determination. We talk about electronic apex locator, which is a non-radiographic method. Electronic apex locators, they're the principal non-radiographic methods, and they are based on the principle. What is the working principle of electronic apex locator? That electrical resistance between two structures. The electrical resistance between oral mucosa and PDL. Between these two tissues, the electrical resistance is always constant, and that constant value is 6.5 kilo ohms. That constant value is 6.5 kilo ohms. This is the working principle of electronic apex locator. So whenever we would insert a file inside the tooth connected to an electronic apex locator and a lip clip is placed in the patient's mouth, the lip clip would contact the oral mucosa, and when the file reaches the PDL, the electrical resistance between the two structures would be what? 6.5 kilo ohms. And when this resistance is met, there is a beep on the electronic apex locator, which indicates that you have reached the PDL or you have reached the full working length. So it basically electronic apex locator, the reading 0 or apex indicates what? It indicates that the file is contacting the PDL. Now, if the file is contacting the PDL, we are bang at the root apex. And the judgment says that we have to keep the file short of the apex by 0.5 to 1 millimeter. So, whenever an electronic apex locator gives a reading 0 or bang apex, it means it is indicating apical foramen or the major diameter. And ideally, what we have to determine? We have to determine the apical constriction. So again, we would subtract 1 millimeter from the electronic apex locator reading, and that would give you the estimate of the apical constriction, and that would be the working length. So what is important to remember over here? You have to remember that what is the working principle of electronic apex locator? It determines the electrical resistance between oral mucosa and the PDL, which is 6.5 kilo ohms, constant for all human beings. Secondly, whenever an electronic apex locator indicates apex, it means the file is contacting the PDL or the file is at the apical foramen or major diameter. We have to subtract 1 millimeter from that reading to get the working length for root canal procedure. So these are the important aspects of your working length determination in the short form. Okay. These electronic apex locators, they are divided into generations. They are divided into generations, and this classification into generations was given by MacDonald. This classification into generations was given by MacDonald. So, first generation, simple questions come on the electronic apex locator. First generation, they are called resistance based. You have to remember the names of these electronic apex locators. The second generation of electronic apex locator, they are called impedance based. See, resistance and impedance are two physical properties. The first generation measured the resistance, the second generation measured the impedance. The third generation of electronic apex locator, they are called ratio based or comparative impedance based or they are called multiple frequency apex locators. See, again, I am stressing that you have to remember these names by which different generations of electronic apex locators are identified. And the fourth generation, they split the property of impedance. It is a physical property which consists of resistance and capacitance. So contemporary endodontic practice, the third and the fourth generation are available. You have to remember that if the question is asking you about what are multiple frequency apex locators, the first choice answer would be third generation. If third generation is not there in the options, you would stick to fourth generation. They are multiple frequency electronic apex locators. Okay. Then we talk about after working line determination, the cleaning and shaping. The cleaning and shaping of the root canals, which is also called endodontic cavity preparation. And just like we do the tooth preparation on the coronal aspect for the various restorative canals for so boss, this endodontic cavity preparation, just like your coronal cavity preparation, consists of two things. There is a resistance form and there is a retention form. There is a resistance and retention form. Resistance form means there is an apical stop. We develop an apical stop in the tooth preparation. It prevents extrusion of material. Okay, beyond apex. Means whenever we clean and shape the root canals, we have to develop an apical stop. This would prevent the root canal obturation material from going downwards beyond the apex. This is known as creation of an apical stock that prevents anything that is used for obturation of the root canal from going beyond the root canal domains. Retention form, on the other hand, it is called development of nearly parallel apical walls of root canal. We are talking about cleaning and shaping of the root canals, isn't it? So development of nearly parallel apical walls of the root canal that prevent, okay, coronal displacement of coronal displacement of filling materials. Means we would prepare the root canals in nearly parallel walls in the apical one third, so that if there is a root canal obturating material, okay, like this, it is prevented from being displaced coronally. So prevention of coronal displacement, the instrument or your obturating material, it should fit snugly at the working length that you have determined previously, should not be displaced either apically or coronally. That is known as this development of retention and resistance form. Okay, so you have to differentiate between what is retention form and what is resistance form. Now, if we talk about methods of cleaning and shaping of the root canal, different techniques are available for the cleaning and shaping. The first one that was given in the year 1961 by Engel is the standardized technique. Standardized technique, one of the simplest techniques for the cleaning and shaping of the root canal. This is also called single working length technique. Single working length technique. Why single working length technique? Because each and every instrument inserted into the root canal would be taken to the same working length. Okay. And the sequence of preparation is from smaller to larger. In the standardized method, the sequence of preparation is smaller to larger. Suppose this is the root canal that we have to prepare, and suppose the working length that is determined is 20 millimeter, then we would take the smallest file to bind it working length. Smallest file to bind at working length. And suppose that is number 20K file. It can be number 10, it can be number 15, it can be number 8, depending upon the geometry of the root canal as well as the configuration. Okay. So what we have to remember that the smallest file to bind at the working length is selected. It is taken to the full working length, which in our example we have taken as 20 millimeter, and then we do circumferential cleaning and shaping. We would then proceed to the next higher size, that is number 25 size, which is again inserted to the full working length, and we do cleaning and shaping in a circumferential manner. Circumferential cleaning and shaping means all the walls of the root canal are cleaned and shaped. We have already seen what is the filing motion in one of the previous sessions where I discussed about endodontic instruments. Then we would take the next higher size, set it to again working length, and do cleaning and shaping. So what you have to remember, it is called single working length technique, of one of the simplest techniques to be used for cleaning and shaping of the root canals. Each and every instrument is taken to the full working length and cleaning and shaping is done. And what is the sequence from the smallest to the largest? And the last file that is used inside the root canal is called master apical file. MAF stands for master apical file. This is how we do cleaning and shaping with the standardized technique. In the year 1969, Clem and Wien, they gave step back preparation. Step back preparation. Step back preparation has been modified over the years with several methods called telescopic preparation, telescopic preparation of the root canal, or it is also called serial preparation. These are the different names for the same technique, that is step back. Basically speaking, sequence of preparation is again from the smallest to the largest. We follow the same sequence from the smallest to the largest. So it is divided into phases. The first phase is the apical preparation phase. The apical preparation phase. The first phase. This apical preparation phase is same as the one that we have seen with step back standardized technique. Okay. Suppose this is the root canal that we have to prepare with the step back preparation, and suppose again the working length is 20 millimeters. Then in the first phase, the sequence remains the same. We would start with the smallest file to bind at the working length. Suppose that is number 15 file. We take it to working length and do cleaning and shaping. We take the next higher size again to the full working length and do cleaning and shaping. Next higher size again to the full working length and do cleaning and shaping. So you can see the apical preparation phase, or the phase 1 of step back, remains exactly the same as your standardized technique, but the sequence remains the same, that is from the smallest to the largest. And the last file to be used to the full working length is called what? It is called master apical file. The largest file to reach the working length is master apical file. Okay. Now the second phase is step back phase. Step back phase. As the name indicates, step back. The next higher size after 25, that is 30, is taken to 1 millimeter short of working length, and we do cleaning in shape. We are stepping back from the apex. So each subsequently larger file would be taken 1 millimeter short from the working length. Next would be 35. It would be taken 2 millimeter short from the working length, or 1 millimeter short from the previous file. Cleaning and shaping. Next higher size would be taken 3 millimeter short of working length, and cleaning and shaping was done. This is called step back. We are stepping back from the root apex, moving for upwards. That's why it is called step back preparation. And then there is phase 2A and phase 2B, which together constitute the refining phase. Refining phase. What is phase 1? Apical preparation. What is phase 2? The phase 2 is step back, and the phase 3, instead of calling it 3, we call it refining phase 2A and 2B. In 2A, what is done? GG drill. All of you must be knowing what is GG drill. We have already discussed GG drill in one of the previous sessions. GG drill is used for coronal flaring of root canals. GG drill is used for coronal flaring of the root canals. Okay. And in 2B, what we do, we use master apical file. All of you now know what is a master apical file. The last file to be used, or the largest file to be used to the working length, is called master apical file. This master apical file is used to do cleaning and shaping once again, which gives a smooth and tapered preparation. So this is known as step back preparation. Okay, we are stepping back. Then the third type of technique is called balanced force technique. Balanced force method. Balanced force method of root canal preparation was given by Rowan, and it is based on pure rotary motion. The root canal preparation is done only with the rotary motion. Rotary motion means circular motion inside the root canal. All of you must remember that if we have to speak in the strictest sense, the principal filing motion is what? It is up and down motion, isn't it? It is called pulling and rasping motion. If you remember, we have differentiated between the reamers and the files, and the filing motion is a pulling and rasping or up and down linear motion, isn't it? But in case of balanced force technique, we would use a file in a rotary or circular motion only to prepare the root canal. And suppose these are the cross sections of the root canal as we see from above. And this is the root canal that is to be prepared with the balanced force technique. We imaginarily divide the cross section of the root canal as we see from above into 4 quadrants. Okay. Now, here the sequence of instrumentation is different from the previous two techniques, largest to smallest. So basically it works on crown down approach. Crown down approach. Isn't it? Crown down means from above downwards. In the standardized and in the step back technique, we were preparing the apical 1/3 first, then the middle 1/3 and the coronal 1/3. From down above. This is from above down. So the sequence would be largest to the smallest. So what we do, we take the largest file that binds in the coronal 1/3 of the root canal. Okay, and we rotate it 90 degrees clockwise. CW stands for clockwise. You would take the largest file to bind in the coronal 1/3 and rotate it 90 degrees clockwise. The file is like a screw, it would engage the walls of the root canal. Now you would rotate the file 270 degrees counterclockwise or anti-clockwise. Okay, so if I take a screw and rotate it clockwise, it goes inside. If I rotate the screw counterclockwise, it has a tendency to come out, isn't it? Similar is the tendency of the file. When you rotate it 270 degrees counterclockwise, the file would tend to come out from the root canal from its depths of insertion. You have to prevent the file from coming out. So what you would do, you would maintain an apical pressure on the file. But there would only be a rotary motion, clockwise, counterclockwise. So when you do not allow the file to come out but rotate it 270 degrees counterclockwise, it would machine or cut the dentine and enlarge the root canal. Now again, you would give it a 90 degrees clockwise turn. It would go deeper inside the root canal. From its previous depth, it would go deeper. Okay, then again 270 degrees counterclockwise with apical pressure. So clockwise, counterclockwise, clockwise, counterclockwise, we keep on doing it and the depth of insertion of the file increases. We would then switch over to a smaller file and then again do the same thing. So the files are only rotated clockwise and counterclockwise, and that's why this is called balanced force technique. And once we have reached to the working length with the file would be withdrawn from the root canal, not pulled out. Remember, it's a balanced force technique. We would never pull out the file in a linear motion. For removal of the file also from the apical 1/3 outside the root canal, you would follow the same rotary motion, that is clockwise motion. We give the file a long clockwise turn and pull it out. So this is the balanced force technique of root canal preparation. Then we have another technique, that is non-instrumentation technique or NIT. Non-instrumentation technique. Non-instrumentation, as the name indicates, in the contemporary endodontics, more and more stress is given to the cleaning and flushing of the root canals with chemical irrigants rather than more shaping and removing the dentine. So mechanical preparations are given less stress and chemical debridement of the root canal is considered to be more important. That's why the concept of non-instrumentation technique came, that we would only clean the pulp chamber with instrument and not insert anything inside the root canals. Insert means no instrument is taken inside the root canals below the root canal orifice. That is known as non-instrumentation technique, and this technique was first proposed by Lucy et al. What did she use? She used a sodium hypochlorite pressure pump to clean root canals. Sodium hypochlorite pressure pump to clean the root canals. Okay. Suppose this is a tooth that needs to be cleaned. Okay. Excess cavity has definitely been repaired inside this tooth. All the pulp from the coronal pulp chamber has been removed, and now we have to clean the root canals with the non-instrumentation technique. Then a rubber cup is cemented onto the pulp chamber, and through this rubber cup we insert a sodium hypochlorite pressure pump inside the pulp chamber. This is sodium hypochlorite pressure pump, and this, at the side of this there is an evacuation tube. So with pressure, sodium hypochlorite is pumped inside the pulp chamber, and because of its low surface tension, it would seep down the depths of the root canal and chemically debride the root canal. And whatever excess solution is there, continuously it is being flushed out. So this is non-instrumentation technique. And all of you must remember that sodium hypochlorite has an important property, that it acts like a tissue solvent. It dissolves the organic tissue like pulp. So it is delivered with pressure inside the pulp chamber through a sodium hypochlorite pressure pump. And because of its low surface tension and ability to dissolve the organic tissues, it seeps down and removes all the necrotic tissue from the root canals. This is known as non-instrumentation technique, or no mechanical debridement is given. Okay. Remaining things, if you remember in the previous sessions, we root canal preparations. Okay. Preparations where we have used light walker, etc. So you can revise those sessions and you would know that what are the other methods of root canal preparations. Okay. In the third section of root canal procedures, we would talk about obturation. After cleaning and shaping, we have to rely upon obturation of the root canal. Root canal obturation principally consists of two things, or two materials are used. Okay. One are the sealers. We have already spoken about the root canal sealers in instruments, materials, and devices session. And we used a core material. This core material can be either a semi-solid material or it can be a solid material. Core material for obturation. This semi-solid material, which is one of the most frequently used material, is gatta parcha, and solid materials can be resin cones. They can be resin cones or they can be silver points. The silver points, they are obsolete. They are no longer recommended to be used for root canal obturation. Okay. So in the root canal obturation, we would talk about methods. The materials and their properties I have already discussed on the session related to instruments, materials, and devices. The first method is cold lateral compaction. As the name indicates, cold lateral compaction of the gutta percha, we would not use any form of heat inside the root canal. The instrument that is used is a spreader. Spreader is a smooth and tapered instrument with a pointed tip. A smooth and tapered instrument with a pointed tip is known as spreader, root canal spreader. It follows the same color coding, same ISO specifications as we have already seen for the endodontic instruments. So whenever I take the sessions, you must know that I take them in a chronological or sequential manner. So whatever knowledge you have gained in the previous sessions is useful in the forthcoming and the current sessions. So if you follow all these sequence, it would be covering my subject in a chronological manner from the earliest to the latest. So cold lateral compaction is used in the spreader, that is a pointed tip instrument is used. There are principal two steps for this cold lateral compaction. One is your master cone selection, and another is your spreader selection. Master cone selection and spreader selection. See, master cone selection we have to do in a wet canal. Why wet canal? Why? Because whenever we would be obturating the root canal is always coated with some sealer. So before putting the sealer, we have to select the master cone, and that selection of master cone is done in a wet canal and not in a dry canal to simulate the actual obturation conditions. Okay. So in master cone selection, we have to see that this master cone is confirmed radiographically, which is called master cone radiograph, and it should fit snugly at your predetermined working length. Definitely working length has already been determined. So it should fit snugly at working length, and this is called tug back feeling. Tug back feeling. There's a feeling of tug back. Tug back means there is retention form. Retention form, I have already told you in cleaning and shaping, means the master cone should not be displaced coronally. Okay, it should fit snugly at the working length. That is called clinical tug back should be there. And whenever we confirm it radiographically, it should fit at the working length. One question that is related to the radiographic fit of master cone is that there is a wiggly appearance of master cone. Wiggly appearance of master cone. MC stands for master cone on radiograph. You have fit a master cone inside the root canal and taken a radiograph. There is a wiggly appearance. Means this is the root canal and this is your master cone. It would appear on a radiograph like this. This is called wiggly appearance, twisted appearance. This is due to why it happens? It happens due to obstruction in the root canal. So question and the answer, remember, like this. It happens due to obstruction in the root canal. Due to some obstruction in the root canal, the cone fails to reach the full working length, and due to pressure on the cone, it has a wiggly appearance. Okay. Then spreader selection. After master cone selection, we take the spreader selection. Spreader should fit. We have to select a spreader which should fit 1 to 2 millimeter short of working length. The spreader should not reach the working length, but it should fit 1 to 2 millimeters short of working length. So size of spreader would be larger than size of the root canal, size of the master cone, isn't it? If it is equal to the master cone, it would go to the full working length. But what we have to choose? We have to choose a spreader that is 1 to 2 millimeters short of the working length. Okay. Second thing is spreader taper. Taper of the spreader. Okay, we know that instruments are tapered. They can be 2 degrees, 2% taper, 4% taper, 8% taper, 10% taper, like this. So taper of the spreader, we have to select which matches canal taper. So we have to select the size of the spreader and the taper of the spreader accordingly. So master cone should reach the full working length and the fit would be confirmed radiographically. The spreader should be 1 to 2 millimeters short of the working length and the taper of the spreader should match the taper of the prepared root canal. We have prepared a root canal with a 2% taper, select a spreader with 2% taper. If you have prepared the root canal with 4% taper, select a spreader with 4% taper, and so on. So these are the important points related to cold lateral compaction that you have to remember. How the master cone is selected, in what condition we check the master cone, what is wiggly appearance of the master cone, how do we select the spreader, what are the factors related to taper and size of the spreader. Simple and straightforward questions come on all these things, but you have to remember these basics. The second method of root canal obturation is warm vertical compaction. Warm vertical compaction. This technique was proposed by Shielder, and the instrument that is used for warm vertical compaction is a plugger. Not a spreader, but a plugger. Plugger is again a smooth and tapered stainless steel instrument, but with a flat tip. Instrument with a flat tip. With a sharp tip, spreader. With a flat tip, plugger. Okay. Warm means we would use a heated plugger. Okay. When the plugger is heated on the flame, it should be cherry red in color. Okay. There can be electrically heated pluggers. Electrically heated pluggers also. Electrically heated pluggers, the examples are Endotech, Touch and Heat, System B. These are examples of electrically heated plugger. Okay, but what is to remember, pluggers have a flat tip. Okay, in this case, whenever we have to do about master cone selection, the important point to remember is that the master cone should fit 0.5 to 2 millimeter short of working length. Okay, it is short of working length and not up to the working length, unlike in the previous method, that is cold lateral compaction. In warm vertical compaction, the master cone should fit 0.5 to 2 millimeters short of working length. So what we would do practically, this is the prepared root canal and this is the master cone that would be seated inside the root canal. Okay. This master cone should be 0.5 to 2 millimeter short of working length. And then we take a plugger that is heated and apical pressure is applied with that plugger. This is heated plugger. Warm vertical compaction. We would heat the plugger, whether it is electrically heated or manually heated on a flame, and apical pressure is applied so that the gattaparcha master cone would melt and flow apically and laterally. This leads to full filling of the root canal, obturation of the root canal to the working length. If you are keeping it exactly at the working length and you put a electrically or manually heated plugger, the gattaparcha would flow and go beyond the apex. There would be loss of resistance and inadequate obturation. Inadequate in the sense non acceptable obturation, because we have to obturate the root canal confines only. Nothing should go beyond the apex, nothing should be short of the apex. Adequate obturation should be there. Okay, that's why we keep it 0.5 to 2 millimeters short. If I have to talk about principal advantage of warm vertical compaction, definitely better apical sealing. If I have to talk about principal disadvantage, then there are chances of vertical root fracture due to pressure from the plugger. The plugger acts like a wedge inside the root canal. When we place a heated plugger and force it apically, there are chances that it can split the root, resulting in vertical root fracture. Advantages and disadvantages. The third method is chemically plasticized gattaparcha. Chemically plasticized gattaparcha, as the name indicates, we use some chemical solvent to soften the gattaparcha inside the root canal. 5 solvents are available that can plasticize the gattaparcha. Chloroform, that is CHCl3. Halothane, which is also a general anesthetic. Eucalyptol, which is oil of eucalyptus. Xylene, that is a organic chemical, and turpentine. These 5 solvents can be used to chemically plasticize the gattaparcha inside the root canals so that they flow. Instead of heat, we are using a chemical to make the gattaparcha flow inside the root canal. And out of them, one of the best solvents for gattaparcha is chloroform. But we can use either of the 5 available solvents. Then we have thermomechanical compaction. Thermomechanical compaction of gattaparcha means some sort of mechanical device is used to generate frictional heat inside the root canal. Instead of directly heating or using a chemical, we are softening gattaparcha by some form of frictional mechanical energy, and the device that is used for this method is Mach Spaden compactor. Mach Spaden compactor. This is a device like this, a rotary device like this. This has a reverse H-file design. Reverse H-file design, Mach Spaden compactor. What is done? This is the prepared root canal, suppose. We select a master cone, which is placed inside the root canal. Okay, alongside the master cone, we place the Mach Spaden compactor. And this is rotated at 20,000 RPM. 20,000 RPM. Okay, this would rotate inside the root canal at 20,000 RPM, Mach Spaden compactor. And because of the rotation, it would generate frictional heat, thermomechanical, and it would soften and make the katta parcha flow apically and laterally to the full working length. So again, the master cone is short of working length in this method. The device is max pad and compactor. Then we have thermoplasticized katta parcha. We have seen methods which are using some form of mechanical, chemical, or heat energy to soften the katta parcha. In thermoplasticized katta parcha method, there is direct injection of liquid katta parcha in the root canals. Injection of liquid katta parcha inside the root canal. This is known as thermoplasticized katta parcha. Okay. What are the devices available? We use obtura, which is a high heat method. Temperature up to which katta parcha is heated is 160 degrees Celsius. So it's basically a gun-like device into which a cartridge of katta parcha is there. And there is a silver needle available in 20, 23 and 25 gauge. Silver needle are used. Okay. Inside this gun, the katta parcha cartridge is heated to 160 degrees Celsius. When we press the plunger, the liquid katta parcha comes out, which is a temperature of 70 to 72 degrees Celsius. So remember, what is the temperature of the katta parcha which comes out? 70 to 72 degrees Celsius. What is the temperature up to which katta parcha is heated inside? Is 160 degrees Celsius. There is direct injection of liquid katta parcha inside the thermoplasticized obturation. The second method is ultrafill. Ultrafill method. Ultrafill is basically a low heat method of thermoplasticized katta parcha obturation. Low heat method. Low heat means the temperature of heating the katta parcha is 90 degrees Celsius. Ultrafill method. It consists of, instead of silver, stainless steel needles are used of 23 and 25 gauge to inject the liquid katta parcha inside the root canals. Ultrafill method. Okay. It uses three types of katta parcha. Three types of katta parcha are used with this. Okay. Low viscosity and high viscosity and intermediate viscosity. But what you have to remember that it is a low heat technique because the heating temperature of katta parcha is 90 degrees Celsius. But again, we heat it to 90 degrees and inject the katta parcha directly into the liquid form. That's why it is called thermoplasticized method. Then we have variable heat methods. Instead of a fixed temperature of heating, there are variable heat methods. Three examples of variable heat method for thermoplasticized obturation are calamus, hot shot, and elements. Third example, fourth, and the fifth. These are the five commercially available devices for direct injection of liquid katta parcha inside the root canal. These are called thermoplasticized obturation methods. Okay. Variable heat technique. Because the temperature is variable, we can set the temperature with a thermostat that is available on the devices. But in case of obtura, it is fixed 160 degrees Celsius. In case of ultrafilm, it is fixed 90 degrees, respectively called high heat and low heat techniques. So these are the principle and the techniques for the obturation of the root canals. So we conclude with this the session on root canal procedures. We have talked about the important aspects of the working line determination, cleaning and shaping, and obturation of the root canal. Thank you very much for being with me in this session. With this, I sign off and see you again next month with another interesting topic related to the subject of consonant. Till then, happy reading, happy Diwali, all of you. Best wishes from my side. Take care. Good night.